Okay, we are back with some quick math. We are dealing with some grade 12 content. This is Euclidean Geometry. I hope you can all see that. So I've read the description. All the information is given on the picture, so we're not going to read through that again. But let's jump straight into this. So we're trying to prove that MC is a tangent. Okay, so let's go look where MC is. MC is over here. Let's check. MC is over there. And if MC is a tangent to your circle, so if it is, so we don't know that it is, but if it is, then you would know, let's just see something's over here. You would know that this angle over here, which is C1 and 2, would be the same as angle B, which is X, okay? You could also then know C2 would be the same as A1, okay? So if it is a tangent, those are some of the things that you know. So now you must try and ask yourself this. Is there some way that you can prove those things to be true? So can you maybe somehow show that C1 and C2, can you show it's X? If you can, then you've proven your tangent. Okay, so let's go ahead and let's try that. Let's somehow prove C1 and C2 is X. So let's start by doing this. If you are dealing with this triangle that's over here, you see your 90 over there, you see your X over there, you can refer to A2, angle A2. You can say that A2 is equal to 180 degrees minus the 90 minus the X. So we're saying in this triangle over here, A2, which is over there, is equal to 180 minus the other two. The reason for this is interior angles of your triangle. Yep, so if we simplify that, that leaves us with 90 degrees minus X. So now we have an expression for A2, right? But we'll also know that A1, so A1 over there is also going to be X, okay? So why do we know A1 is X? Because these are the same length, okay? So if they are the same length, then A1 must equal to A2. And we've already said that A2 is equal to 90 degrees minus X. The reason for this is equal chords, equal angles. Yep, so if you have equal chords, you have equal angles. I think that's our fourth theorem, something like that, right? So what we are saying is we are saying that this angle over here, that angle over there is 90 degrees. Not 90 degrees, is 90 minus X. So if I look in this triangle that I have here, triangle AMC, I can then say angle C1 and C2. That's the one we were looking at, right? I can say C1 and C2. So C1 plus C2. That will equal to 180 degrees minus M is 90, minus A1. Right, and our reason again, so I'm running out of space. Okay, I can put it there. Interior angles of your triangle. Okay, let's zoom out again. Okay, so we are saying C1 and C2 is that M, which is 90, and the A1, we take those two away from 180, and that will give you C1 and C2. So what is C1 and C2 equal to then? C1 and 2 is equal to 180 minus 90. It's going to be 90 minus A1. A1 is 90 minus X. Okay, so that's nicely, that goes inside. It's going to be minus 90, so it's going to disappear, and that's going to give us positive X. So what have we proven? We've proven, let's go look at our picture again. We've proven that this angle over here is X. We already know that this angle is X. So that's what we said when we started this question. We said if we can somehow prove that they are equal to each other, we have our cyclic quad. So now let's go make the statement that B is also equal to C1 plus C2, right? So all of these are X. And if all of them are equal to each other, then we can say, therefore, is it MC? Therefore, MC is a tangent. Right, so MC is a tangent, and your reason. So now you need to say, why is it the tangent? So we know that if it was a tangent, you would be able to say tan chord theorem for them being equal to each other. So now, because you've proven that they are equal to each other, and you're using the fact that they're equal to each other to prove that it's a tangent, you have to go for converse of your tan chord. Okay, let me just write that there. So converse of tan chord theorem. Okay, I'm running out of space, but you know that it should be tan chord theorem. Okay, so let me just talk through the question again. What did we actually do? Okay, so here in this first triangle, we said that A2 is 180 minus these other two angles. Okay, then we said we know that we know A2 and A1 are the same thing. Why? If these two chords are the same length, they have to subtend equal angles. Equal chords, equal angles is your reason there. Okay, and then we said, okay, if you are in this triangle over here, then again, same thing. C has to be 180 minus your M and minus A1. Okay, interior angles of a triangle. That's how we proved that C1 and 2 together is X. And since C1 and 2 is X and B is also X, tan chord theorem, well, the converse of tan chord theorem will tell us that CM is a tangent.